of you know about how to make dimensional formula. Okay, so now our next topic is how to check the equation is dimensionally correct or not. Okay, so fine, now we have to discuss today our method 1. Okay, the equation is dimensionally correct or not. Okay, so here we have to take one example. Like example is one of the equation. It is a 1/2 mv square equal to mgh, where 1/2 mv square is indicating as a kinetic energy, and this equation of the kinetic energy, and this equation of the potential energy. So both are the energies equations. Okay, so if we know that the this equation is dimensionally correct, but after proof, what is a proof? So there is a proof. First of all, we have to indicate what is m. M is a mass of the body. What is a v? V is a velocity of the body. What is m? Again, it is a mass of the body. G is a gravitational acceleration. Okay, due to the gravity, the acceleration is coming out of the body. It's known as the gravitational acceleration, and h is known as the height of the object. Okay, now height now, and h is known as a height. Fine, how we prove that? So we prove that after this equation. So here we see that now we have to take as an equation like from the left hand side and from the right hand side. So this is our left hand side and this is our right hand side. So now from the left hand side, what is the equation of the left hand side? Is equal to 1/2 mv square. Okay, so now we have to make each and every point of the dimension formula. Now the 1/2, first point is a 1/2, first term is a 1/2. So 1/2 is a constant term. 1 is a constant, 2 is also constant. The constant is a dimensionless. Now this m is indicating the mass, so mass is we represent a capital M to the power 1. Now v is the velocity square. Now what is the velocity? Velocity is a displacement upon time. Displacement we have to indicate L to the power 1 upon time T to the power 1. So whole the power of 2. So we can write down as a L of the power 2, and this time is goes numerator. So T raised to the power of -2. Okay, now so for the LHS, it is a 1/2 mv square. The dimensional formula of this term is m1L2 T minus 2, and this is also the dimension formula of our energy. Okay, so whatever energy, it is a potential energy, kinetic energy, our dimension formula is this. Now from the second thing we have to discuss now our right hand side. So what is our right hand side? So our right hand side is a mgh. Okay, this is our right hand side. So right hand side equal to mgh. Now the first is indicating the m is known as a mass. G is a gravitational acceleration. What is g? G is known as a this here. Okay, we have to represent it is a gravitational acceleration. Okay, now acceleration, we know that it is a velocity upon time. Okay, velocity equal to distance upon time, so it's a time square. Okay, so now this equation is will be written like that: L to the power of 1 and T to the power of -2. Okay, fine. And the third term is a height. Height is indicating for the length, so it is a L to the power of 1. So now the right hand side equal to mgh equal to the dimension formula is m1 L2 T to the power of -2. So we have to compare both the equation from left hand side and the right hand side. From the left hand side equation is m1 L2 T -2, and from the right hand side equation is m1 L2 T -2. Oh, here the RHS equal to LHS, so we can consider the equation is dimensionally correct. Okay, now here I will make one of the example. Now the one of the example is also k equal to 1/2 mv square. So just we have to prove that. So this k is indicating for the kinetic energy, and 1/2 mv square is also indicating for the kinetic energy equation, but we have to prove that. Okay, now k is for kinetic energy, m mass, v velocity. So from the left hand side we have to take this kinetic energy, and right hand side we have to take 1/2 mv square. So our equation is like that. Okay, so what is our equation? Now from the left hand side it is a k is a kinetic energy. Now what is the energy equation? The dimension formula of energy is a force into distance. Now force into distance, force equal to mass into acceleration into distance. Mass acceleration equal to velocity upon time into distance. So our dimension formula of energy is m1L2 T -2. Now we have to compare with the right hand side. So what is our right hand side term? Our right hand side term is a RHS equal to 1/2 mv square. So it's a 1/2 is a constant, dimensionless, m is indicating for the mass, velocity is a displacement upon time, it's a L2 t minus 2. If we together these three all of the term, okay, so right hand side term is a 1/2 mv square, it is a m1 L2 t minus 2. If we have to compare with LHS equal to RHS, so the left hand side term and the right hand side term both are same. So we can say that this equation is dimensionally correct. Okay, now so here the one of the example, or example number 3 and example number 4, you have to do by yourself. Okay, you have to do by yourself, and if check it is dimensionally correct or not, and you have to write in a comment. Okay, thank you. In this method we have to make a equation. Okay, so we have to make a equation of the fundamental description. Now what is the description? Just we have to see that. First we have to write, consider a simple pendulum having a bob attached to a string, okay, that oscillate under the action of the force of gravity. Now suppose that the period of oscillation of the simple pendulum is depend upon its length, mass of the bulb, and the acceleration of the gravity g, and derive the equation of its time period using the method of dimensions. Okay, now so what is this in this case? So just you to remember the period of oscillation. The period of oscillation is t. Just you can write it depends upon the time of period is depends upon, so we have to take the time of period is depends, it is a proportionally, okay, the length, it is a L to the power a, so we have to represent as a power. Mass of the bob, it is the mass of the bob, m to the power of c, and acceleration due to gravity, so acceleration gravity with the power g to the power of b. So we can write like that. Okay, and we have to prove a equation of a simple pendulum. Okay, so we have to express the equation of the time period using dimension formula. Okay, fine. Now so I will show you the one thing. This is a fixed support, and this is a string, and this is a bob, and this is a simple pendulum. Okay, due to gravity this is a g, it is with respect to the ground, it is a gravitational acceleration. Yeah, we know that the equation of simple pendulum is t equal to 2 pi root L upon g. Okay, so we have to prove that how this is becomes. Okay, now first once again I will tell you, okay, how we can write this equation. All of these parameters are right in a product. Okay, so first once again the period of oscillation is a t, is directly proportional to, because it here right series depends upon length, mass, and g, so L, g, and m. Okay, whatever in order, so we can arrange anytime. Okay, anything. So L to the power of a, g to the power of b, and m to the power of c. But how we can prove that? So if we can prove that, then just you have to see that. Now if we have to remove the proportionality, just we have to take a constant, and constant is k. So our equation will be t equal to k L to the power of a, g to the power of b, and m to the power of c. Just make a equation number 2. Now so when we have to check the both side, from left hand side and right hand side dimensionally. Okay, so now our equation will be from the left hand side equal to t only. Okay, this is our left hand side. So t, the equation of t is a time of period, it is a m0, L0, and t1. Okay, now from right hand side, the right hand side equation is a k. K is a constant and it is a dimensionless. Now what is L to the power of a? L to the power of a equal to L to the power of 1. L is indicating the length, it is a L to the power of 1 to the power of a, so we can say that it is a L to the power of a. Second, g. Now what is g? Is a gravitational acceleration. Yeah, we know that. Okay, the gravitational acceleration is a displacement upon time square. Yeah, we know that. Okay, the power of b. So L1 displacement time square, t2 power of b, this t goes numerator, t1 L1 t minus 2 power of b. So we can write like that, L to the power of b and t to the minus power of 2b. Okay, term is our in the right hand side equation. The right hand side equation is a mass. Okay, L, just L e to the power of a. What is a g? G, it is a L to the power of b and t to the power of minus 2b. Now what is a m raised to the c? So m is indicating the m. So now the m is indicating the mass. So mass is a m to the power of 1, it is a mc. Okay, now we got it. Now from the left hand side and right hand side. Okay, now what is the left hand side equation? It is a m0 l0 t1. What is the right hand side? The right hand side there is a three term: length, gravitation, and the m mass. Okay, now so if we arrange this term, okay, so this is a m0 l0 t1. Now m to the power of c, l to the power of these a and b, base are same, power addition, a plus b, t to the power of 2b. So we can write like that. So m0 l0 t1, and if we have to write like that, m to the power of c, l to the power of a plus b, and t to the power of minus 2b. Now what we have to do? Just we have to do in both sides the equation from the left hand side and right hand side. The base are same, so we have to compare the power of this fundamental quantity. Fundamental quantity is a mlt. Okay, so we have to compare the power. So first m to the power of c, m to the power of 0. M to the power of 0 equal to m to the power of c. So we can say that c equal to 0. Got it? Second, L to the power of a plus b, L to the power of 0. So L to the power of 0 equal to L to the power of a plus b. So we can write a plus b equal to 0 and a equal to minus b. Now third, the t to the power of minus 2b, t to the power of 1. So t to the power of 1 and t to the power of minus 2b. So we write down here 1 equal to minus of 2b. So b equal to, just go down 1 upon minus 2. So we can write here b equal to minus 1 by 2. Okay. Now from this equation we have to arrange the value, just put the value of this b in 2. So this put the value of b in this 2. So a equal to minus plus 1 half. Okay, so a equal to plus 1 by 2, a equal to plus 1 by 2, b equal to minus 1 by 2, and c equal to 0. Now these all three value of a, b, c are put into the equation number 2. So what is our equation number 2? Our equation number 2 is the t equal to k l raised to the power of a, g raised to the power of b, and m raised to the power of c. And we have to put the value of this in equation number 2. Equation number 2 is like that. Okay, so k is a constant, l to the power of a is a 1 by 2, b is a minus 1 by 2, and c is a 0. But anything raised to 0 will be a 1 mathematically. Okay, now t equal to k raised to the k into l raised to the power of 1 by 2 and g raised to the power of 1 by 2. But we can say that the power of 1 by 2 is also known as a root. Okay, so root l upon root g. So whole of root of l by g. This is the equation of pendulum. But for by experimentally we have to take as a t constant k equal to 2 pi. So our equation will be t equal to 2 pi root l by g. Okay, fine. Now here another example. Okay, so now in this example the centripetal force depend on the mass of the body for m, velocity of the body v, and the radius of r. Then derive the equation of formula for centripetal force of F by dimensional analysis. So what you have to see in this example? So for first of all, centripetal force. So centripetal force equal to F. It is a directly proportional to, because it is a depends means it is a directly proportional to. Okay, in which parameters? First is the mass of the body. It is a m to the power of a. Okay, velocity of the body, it is a v to the power of b, and third one is known as a radius. Okay, so r to the power of c. Understood? Now if we remove the proportionality, we have to put here a constant k. Okay, now this our equation will be f equal to k m to the power of a, v to the power of b, and r to the power of c. Now we have to check this equation from the dimensional equation. Okay, now from the left hand side we have to see that F, force. So what is the force? Force equal to mass into acceleration, but acceleration equal to displacement upon time. So our equation m1, it is a displacement upon time square, it is a L1 t raised to the power of minus 2. So from LHS equal to this. Now from right hand side, it is a mass, velocity, and r. So mass, the power of a, it is a ma, velocity, it is a L1 t raised to minus 1. So LB t raised to minus of b, and the third one is known as a RC. Okay, so radius to the power of c, it is a distance Radius is indicating as a distance. Okay, so L to the power of 1 to the power of c equal to L to the power of c. Now just compare these two equations. Okay, now just compare these two equations from the right hand side to the left hand side. Okay, now what is the left hand side? It is a this. It is a this m1 l1 t minus 2. It is a m1 l1 t minus 2. Right hand side, now it is a k ma vb rc. K ma, yes, this vb is a lb into t raised to minus b. So this here lb t raised to minus b, and third one is known as the lc. If rearrange this equation, the equation will be written, this is the left hand side and this is a right hand side. Now from this we have to compare the power of fundamental units. Fundamental units, you know, m, l and t. Okay, so m to the power of a, m to the power of 1, so a equal to 1, l to the power of b plus c, l to the power of 1, so it's a b plus c equal to 1. So if we can write b equal to 1 minus c, or we can also take like b plus c equal to 1. Okay, now third, t raised to the power of minus b, t raised to the power of minus 2, so b equal to 2. Just we have to put in this equation, so b plus c equal to 1. Okay, now this equation 2 plus c equal to 1, b is equal to 2, c equal to minus 1. Okay, after this we have to find the our three value. What? Our value of a equal to 1, b equal to 2 and c equal to minus 1. Okay, so now these all the values of ABC are put in the equation number 1. What is equation number 1? The equation number 1 is F equal to K, MA, VB and RC. So now our equation F equal to K, M raised to the A, V raised to the B and R raised to the C. Fine. The value of A is 1, value of B equal to 2 and value of C equal to minus 1. So we have to represent like that, F equal to K M V square. If minus 1 is goes in denominator, okay, it is a R. So our centripetal equation force of equation is mv square upon R. Okay, and therefore is a K equal to 1 by experimentally. Okay.